Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum. My name is Sanolla and I am from BE8 Electronics. And I have assigned the presentation of VlSI by Dr. Said Ahmad Khan Abdo, and my CMS ID is 0311700012, and my topic of presentation is the defect and crystals. So first of all, the introduction. Crystalline material has a crystal structure in which the some atom are positioned in the perfect order pattern which is repeated over large atomic distance. Defect have a profound impact on the macroscopic properties of material. Sometimes defects are deliberately created to improve properties of crystals. Crystal defect imperfection in the regular geometrical arrangement of the atom in a crystalline solid. These imperfections result from deformation of the solid, rapid cooling, or from high temperature or high energy radiation. Actually, crystal defect can cause due to the deformation of the solid, or it may be caused due to rapid cooling, or due to high temperature or high energy of radiation, like here I have written like X-rays or neutrons. So next, imperfection in the crystal. There are two types. The one first I will discuss only the one electronics. Electronics are further divided into two types. The first one is due to temperature or heat. Electron disturb. This imperfection is due to the movement of electrons. Chapshe, Aruba, खबरी मको हिसाब है चप किए नहीं मोहम्मद खबरी मको हाँ शोर बने के So this imperfection is due to the movement of electrons, and it is also called a thermal imperfection. If we see in the figure, there is a conduction band and valence band, like I discussed in the class. If we take example of NaCl and valence band, there will be NaCl, and conduction band there will be the ions of Na and Cls, and between the conduction and valence band there will be formatted forbidden energy gap. And imperfection in crystal is caused due to the movement of electrons. Now the imperfection in crystal. Now the second is that it can be formed due to the holes or electrons. They form semiconductor electrical properties like n-type and p-type. If we see in the figure, it is of lithium batteries. Here it consists of anode and cathode. If we give the battery start, so the holes or electrons will be created, so it can cause the imperfection or defect in crystal. Now the second one is the classification of defect in crystal. So actually it is divided into 0D, 1D, and 2D and 3D. So in 0D fine defects, it is fine defects. It further divided into ionic and non-ionic. I will discuss this further, and it is divided into frequency, interstitial, and Frenkel defect and Schottky defect. And 1D line defect divided into edge dislocation, screw dislocation, and surface or interference. 2D divided into grain boundary, twin boundary, and stacking fault. And 3D volume defect, dispersant, precipitate, and inclusion, and voids or cracks. Now, point defects. Point defects are the irregularities or deviation from ideal arrangement around a point or an atom in a crystalline substance. A point defect occur in ionic or non-ionic, as per I said earlier. And when there is ionic and non-ionic misses, actually, if we see in the figure, if there is one whole line miss of electrons or holes, then it cause line defects. We may call it line defects or point defects. Now, point defects types. There are two main types of point defects. The first one is the non-ionic crystals, and the second one is the ionic crystal defect. So, in non-ionic crystal defects, it is further divided into vacancy defect and interstitial defects. In ionic crystal are divided further into Frenkel defects and Schottky defects. Now we will discuss each one by one. Now, non-ionic defects. Non-ionic crystal defects are of two types. Number one is vacancy defects, and the second one is the interstitial defects. Now we can see defects, and we can see defects atom missing from an atomic site occur due to imperfect packing during crystalline. These result in decrease in density of the substance. Actually, there are trillion of atom that will be missed. Like if we see the figure, there is one atom missing, but actually in crystal defects in crystal there may be a trillion of atom will be missed, so its mass and density will be reduced or decreased. So I think it is the disadvantage of it. And now the next one is the interstitial defects. Here we added some extra atom here, addition of some extra atom into the crystal, so it causes interstitial defects. This defect increase the density of the substance because there is an addition of extra atoms that may be holes or electrons to the crystal. So due to addition of extra atoms, the mass and density size will be increase. And like here it causes atomic distortion. We can see an interstitial or inverse phenomena, interstitial form. If you send the figure here as a blue and circle, it is actually added into the crystal. So it will be not be one atom, it may be a trillion of atoms, so its size will be increased. Now the second one is the ionic defects. There are three types of ionic defects. The first one is the stoichiometric defects, the second one is the non-stoichiometric defects, and the third one is the impurity defects. Now, stoichiometric defects. An ionic crystal has a fixed ratio of anion and cations, which can be seen from its formula. This fixed ratio is called stoichiometric of that compound. If a defect in the crystal is such that the ratio between the cations and anions remains same is represented by its formula, the defect is called stoichiometric defect. Actually, stoichiometric defects is the ratio between anions and cations, and we will focus on the formula like sir discussed in the class. Like sugar have C6H12O6. We will see the ratio. We will see the ratio of the formula because there can be a fault due to the ratio like and points like if the ratio is 2:1, like it can be 2:1.1, like something that. And the water H2 and this acetic acid formula is CH3CWH, something like that. So actually stoichiometric defect are further divided into two types. The first one is the Schottky defect and the second one is the Frenkel defects. Now Schottky defects, Schottky defect, it is actually a pair of anion and cation vacancies. In order to maintain electrical neutrality, the number of Mrs. cation anions are equal. Like if you see in the figure right hand side in a red circle, here a pair of one hole and one electron are missed. Here it means a pair of cation and anion are missed. So like anion and one cation is missing, it also decreases in the ACN and KF, etc. Now the second is the Frenkel defects. It is same like the interstitial defects. A combination of you can see an interstitial form. Here no change in the density, because if we see an interstitial defects, the density and mass will be increased, but here there is no change in the density or mass, because here the hole or the electron will move from its place to another place. So if we see in the figure, it is clearly shown. In the same crystal, the cation occupies the interstitial state, so this is the vacancy effect, and it is also interstitial defects. Like here, but mass and density will be same, because there is no emit of ion. Conduction of electricity will occur when one ion goes to the place of other, so high dielectric repel each other, so the dielectric properties increase. While in Schottky defect, dielectric material became same because both ion are close to each other. So actually there will be no change in the density or mass in the Frenkel defects. So that was all about my presentation about the crystal defect and crystal. So thank you so much, and thank you for listening. Thank you so much.